Find the unit digit of 19 raised to the power x plus 27 raised to the power y. So here we have a question in which we need to find the unit digit. So there are several principles of unit digit that we must know, that the unit digits always have the cyclic nature. Cyclic nature means that they always repeat after several powers. That's one of the rules. And the second number is that the unit digit of the number always depends on the unit digit of the question itself. That means 19 to the power x will have the same unit digit as 9 to the power x or 79 raised to the power x. So we can simply do away with any digit other than the unit digit to answer the question. So this question becomes more or less same as what is the unit digit of 9 to the power x plus 7 to the power y. And rule number 1 is they are cyclic. Cyclicity is a principle in which we study that after how many powers does the unit digit repeat. For example, in case of 9, the unit digit repeats after every 2 powers. 9 to the power 1 is 9, 9 square is 81, 9 cube is 729, so after 2 powers the unit digit has repeated. Similarly, in case of 7, the cyclicity is 4, 7 to the power 1 is 7, 7 square is 49, 7 cube is 343, and 7 to the power 4 is 2401, 7 to the power 5 leaves us with unit digit 7 again. That means the unit digit of 7 repeats after every 4th power. These are the cyclicities. Now we will quickly move on to answering the question. The question number 1, the product of x and y is an odd prime number. X into y is equal to an odd prime number. Now, understand one thing. The very first thing that we think in such questions is about the integers. But we should always be able to judge whether the question has given us any reason to believe that x and y are integers or not. And when we read the question once again, we see that question does not mention that x and y are integers. So while the value of x and y may be 1 and 3 or 3 and 1, the values of x and y may also be 6 and 1 by 2 sorts. So while this particular case gives us a unit digit which is 9 to the power 1 plus 7 to the power 3, that will have unit digit 9 plus 3, that is equal to 2. In this particular case, the unit digits will have a different outcome altogether. 9 to the power 3 plus 7 to the power 1 will have the unit digit 9 plus 7 to the power 1 is 7, so the unit digit is 6. Here only we have been able to prove that the given statement is not sufficient because we are getting inconsistent values of unit digit. So out of option A, B, C, D, E, we can do away with two options, options A and option D. Let's check the second statement here. The second statement only gives us x is greater than y. Once again, when y is taken as 1, x can be taken as 2, 3, 4, etc. Many possibilities. Again, not sufficient because the unit digit at different powers will be different for the different values of x. Now, when we combine the two statements, then we need to understand that x into y is an odd prime number where we also know that x is greater than y. So while one possibility that we can take is x equal to 3 and y equal to 1, in which case the 9 to the power 3 plus 7 to the power 1 will have unit digit 9 plus 7, that is equal to 6. If we choose the values of x and y which are non-integers, because if you choose integer values, then always the result will be inconsistent. The result will be consistent. The reason is x for every odd prime value will have the same unit digit of 9 to the power 3. But now if we choose the values such as 6 and 1 by 2, then our result will be 9 to the power 6 plus 27 raised to the power 1 by 2. Because now we are taking power 1 by 2, so we can't just stick to the unit digit of the number. It was 27, so I have come back to the 27 now. While 9 to the power 6 will have the unit digit 1, 27, that means the square root of 27 will be equal to 3 root 3, that will be equal to 3 multiplied by 1.732, that means 5.1. So we will have 5.1, so the unit digit even in this case is 6. Now let's quickly choose some other values. For example, maybe we can choose here the value as 9 and the value of y as 1 over 3. In that case, 9 to the power 9 plus 27 raised to the power 1 by 3 will give us the unit digits 9 plus 3, that is 2. You see, now there is inconsistency in the unit digit. Sometimes we are getting the unit digit of the result as 6 and sometimes else we are getting the unit digit 2. Therefore, even after combining the two statements, the information is not sufficient and the answer to the question becomes option E. The most important part while answering this question that I acknowledge is the absence of the information that x and y are integers. And if we notice it, we would probably get the correct answer. I hope you enjoyed the explanation. Thank you so much.